Now, friends, we move to the next topic, that is what we have as elastic collision. So our next topic is elastic collision. So what is this elastic collision? This elastic collision, it is a type of collision in which both momentum and kinetic energy both get conserved. That means momentum, that is the total momentum before collision, is exactly equal to the total momentum after collision. When the two bodies are moving with different velocities and the collision has taken place, after collision, when they move with again different velocities, but if you observe one thing here, that is the total momentum. Total momentum means sum of the momentum of the two bodies before the collision is always equal to sum of the momentum of the bodies after collision. In the same way, the kinetic energy also will get conserved. The total kinetic energy, I have to use the total kinetic energy in the sense, the kinetic energy of the first body plus kinetic energy of the second body. How many bodies are there irrespective of that? So first body, that is the total kinetic energy I'm using, I was explaining that. So kinetic energy of the first body plus kinetic energy of the second body, if you add it, you'll be getting some result for that, some result. Suppose like we are having two bodies, one is having the kinetic energy 2 joule, other is having the kinetic energy 3 joule. This is before collision. But after collision, if you observe, after collision, what we observe is no doubt the kinetic energies are changed. First, it was having the kinetic energy 2, the second was having the kinetic energy 3 before collision. But after collision, we are seeing that the first one is having the kinetic energy of 1 joule and the second one is having the kinetic energy of 4 joule. No doubt the kinetic energies are different. But if you sum that, if you add the kinetic energies, if you take the total kinetic energy, 3 plus 2, that is 5. And in the second situation, 1 plus 4, that is also 5. So in this way, the kinetic energy also get conserved. The first 2 points what we need to write here is, the first one, momentum is conserved. Momentum is conserved. The second point is kinetic energy is conserved. Both the physical quantities will get conserved here. So based on this, many questions can be framed only based on the concept of this conservations of momentum and kinetic energy. Many questions can be framed. Let us first we see how we are going to deal with these two statements. The first one, suppose for that, what I do, just imagine two bodies are there. This is first one, this is the second one. This is the first body of mass m1 is moving with the velocity u1. The second body of mass m2 is moving with the velocity u2. This is the situation before collision. Collision से पहले की बात कर रहा हूं मैं. Now here if you observe students, here the collision has taken place. यहाँ पे collision हो गया. This is m1 and m2, and after collision the two bodies now they are moving with different velocities. M1 is moving with velocity v1 and M2 is moving with the velocity v2. This is the initial situation. That's why that is before collision u1 and u2. After collision, final velocities, that is v1 and v2. This is the situation what I am considering here. Now, if I apply the first point, the momentum is conserved. How I can apply the first point? What is the momentum of this body? It is m1 u1. m1 u1. What is the momentum of this? Momentum is the product of mass and velocity. So what is the momentum of this two? That is m2 u2. What is the total momentum before collision? So I have to add this two, m1 u1 plus m2 u2. Now come to the situation here, that is after collision. What is the momentum of this body? m1 v1. The momentum of this body m2 v2. Total momentum is m1 v1 plus m2 v2. So what I do here is m1 v1 plus m2 v2. So this is the momentum, total momentum before collision, and this is the total momentum after collision. And for the elastic collision, both must be the same. ये दोनों बराबर होना है, तभी हम जाकर बताएंगे कि भाई ये इलास्टिक कोलिजन है और कोलिजन है. कोलिजन होने के लिए ये कंडीशन जरूर है बेटा. द सेकेंड वन, if you want to apply this condition, kinetic energy is conserved, and you know kinetic energy formula half mv square. Half mv square is the formula for the calculation of kinetic energy. So what I do here is kinetic energy of this body, it is half m1 u1 square. The kinetic energy for this body, it is half m2 u2 square. So the total kinetic energy is what? The first one, half m1 u1 square plus half m2 u2 square. That must be equal to kinetic energy, the total kinetic energy after collision. So let us go with this. This is what? Half m1 v1 square plus half m2 v2 square. Now students, this we are getting two conditions. One condition is for the conservation of momentum, and the other condition we are getting for the conservation of kinetic energy. So what I say here is these are the two important conditions for elastic collision. The next and the very, very important condition for the elastic collision, if you solve these two equations, we'll be getting one condition. That solving part we are not seeing here because we are going for the competitive level. So if you solve these two equations, then we are going to get a very important condition. What is that condition? Let us see. The condition here is u1 minus u2 is equals to v2 minus v1. So what is the importance of this? The importance here is the two importances I'm going to show you. The first one, if you observe this equation, the first equation, I can say the first equation, this equation is depending on mass. That is, involvement of mass is there. This equation also there is an involvement of mass. But the equation what we are getting after solving this, you can solve it. So after solving this, you are going to get that, and that's the only equation which is independent of the mass of the objects. The first important. The second one is we see this is v1 u1 minus u2. What do you mean by this difference in the velocities? That you ought to call it as relative velocity. And u1 and u2 are the velocities before collision. v2 and v1 are the velocities after collision. So here I can say that the relative velocity before collision is equal to the relative velocity after collision. So let me write that statement because that is a very important statement. So here what I do, relative velocity of approach before collision, because before collision they are going to approach. So relative velocity of approach before collision is equal to relative velocity of separation. Why I am writing separation? After collision they will get separated. So relative velocity of separation, and this will take place after collision. So though both the relative velocities are same, so therefore this is an important relation. That's why we take in box. Now students, what we have seen the momentum condition, we have seen the kinetic energy, we have seen the relative velocity, the concept of relative velocities, and from that we have come to a conclusion that in an elastic collision, इस elastic collision में relative velocity before collision जो होता है ना, वो same as relative velocity after collision भी होता है. Now beta, try to understand the next part. What I am showing you here, you can see clearly u1 and u2 are the initial velocities of the objects, and v1 and v2 are the final velocities of the objects. So let us see what are the final velocities, that are v1 and v2 in terms of initial velocities. Let us see. I'll give you the heading that final is the second one, final velocities in term of initial velocities. Final velocities in terms of initial velocities. Pay attention, what is this final velocity? v1. and we are expressing this v1 in terms of u1 and u2. v2 is the final velocity of the second body, and we are expressing this final velocity of the second body in terms of, again, initial velocities of both the bodies, that are u1 and u2. Let us see what is this v1. m1 minus m2 by m1 plus m2 into u1 plus 2m2 u2 by m1 plus m2. This is what I can say the final velocity of the first body in terms of initial velocities. That is the first m1 minus m2 by m1 plus m2 into u1 plus 2m2 u2 by m1 plus m2. This is the final velocity of the first body in terms of initial velocities. Here you are going to get n number of formulas for velocities, but I always ask the students, no need for remembering all the formulas, just you have to remember only one formula. Just you remember one formula. We will just by seeing this first formula we can frame the second one. If and in case of inelastic collision also, there also we have certain tricks to just frame out the formula. You need not to remember that. Okay, so just first one you remember. If I want to write for v2, the same expression for v2 I want to write, that is final velocity for v2, that is v2 is equals to, see students, here v1 means we are writing v2. In short, I am giving you a hint. 1 की जगह पे क्या लिखे बेटे हम यहाँ पे? 1 की जगह पे क्या लिखे? 2 लिखे. तो आप कंप्लीट एक्सप्रेशन में, ये कंप्लीट इक्वेशन में व्हाट यू डू इज, जहां पर 1 है, सब्सक्रिप्ट बता रहा हूं ये वाला, ठीक है, जहां पे 1 है वहां पे आप 2 लिख दीजिए, और जहां पर 2 है वहां पर 1 लिख दीजिए. जस्ट मेक ए चेंजेस, नो नीड फॉर रिमेंबरिंग द फॉर्मूलास. ठीक है, तो यहाँ पे m1 है बेटा, तो m1 है ना, तो व्हाट आई डू हियर इज वी राइट m2. यहाँ पे m2 है, 2 है, तो यहाँ पे हम क्या लिखेंगे? m1 into this is u1, no, so I'll write u2 divided by m1 plus m2, m1 plus m2, but m1 can be written as m2, 2 बनाएंगे हम, और यहाँ पे 2 की जगह हम 1 बनाएंगे, that will become m2 plus m1, but overall you add, you are going to get the same result. तो हम यहाँ पे लिखेंगे m1 plus m2 plus 2 as it is. What is this m2? 2 is there, so we write m1. u2 is there, in place of 2 हम लिखेंगे 1. in the same way यहाँ पे ना बेटा try to understand, अगर आपको confusion होता है तो मैं इसको लिखता हूँ m2 plus m1, but what I was saying is m2 plus m1 लिखिए या m1 plus m2 लिखिए, both means the same, that will not get changed. I hope you have understood. Here कुछ भी आपको याद रखना नहीं है. What I have done here in the on the complete board, you can see momentum is conserved. This is the situation. We know the momentum before collision, momentum after collision, both are same. And kinetic energy is conserved. Kinetic energy का condition लगा दिए. इसको याद मत करिए. Why I am stressing again and again? इसको याद मत करिए, इसी को भी याद मत करिए बेटा. आपको जो condition जो बताया जा रहा है, just remember that, and during exam just you apply the condition. Inshallah 100% you are going to get the result. I hope it is clear. Next. So here, after solving these two equations, we are going to get u1 minus u2. That is equals to v2 minus v1. Relative velocity before collision is equals to relative velocity after collision. And these are the velocities that are final velocities in terms of initial velocity. So on the complete board, what we need to remember, this is the first one, and the second one is this equation. And from this is v2, we are deriving, we are just not deriving, just looking at v1 and we are writing v2. I hope you have understood the complete concept of this elastic collision. Now students, we move to the special cases for elastic collision, and these special cases you can expect as the question itself in your final. Okay, so we are going to discuss the special cases one by one. अच्छे से समझिए, देखिए यहाँ पे the first one, special cases, that is the case 1. This is the case 1. Both bodies are in motion. That means the bodies which are undergoing a process called collision, they are both are in motion, that is before collision. So what we do here is both are in motion, but additional condition we are having here is m1 is equal to m2. व्हाट डू यू मीन बाय दिस? क्या मतलब है बेटा इसका? इसका मतलब ये है दोनों बॉडीज जो मूव हो रहे हैं बिफोर कोलिजन, दोनों के मासेस एग्जैक्टली इक्वल हैं। अब ये एग्जैक्टली इक्वल है तो व्हाट वी कैन एक्सपेक्ट, लेट अस सी। देखिए यहाँ पे द फर्स्ट कंडीशन व्हाट आई डू हियर इज द वेलोसिटी, फर्स्ट वन हम लिखेंगे m1 माइनस m2 इंटू u1 बाई m1 प्लस m2 प्लस 2m2 2m2 u2 by m1 plus m2 2m2 u2 by m1 plus m2. This is the first what we have seen. The second one, if you see, just I asked you to replace that m2 minus m1. देखिए बेटा m1 है यहाँ पे m2 लिखेंगे, 2 है यहाँ पे 1 लिखेंगे, तो it is what u2 by m1 plus m2 plus this can be written as 2 m1 and this is what u1 by m1 plus m2. So this equation just we have seen, that I'm just recalling it. Actual condition now we are going to see. देखिए बेटा दोनों बॉडीज है मोशन में है एंड दोनों के मासेस क्या है, इक्वल भी है दोनों एग्जैक्टली। अगर एक बॉल का, एक स्फीयर का मास है 1 kg, दूसरे स्फीयर का मास है 1 kg, तो व्हाट इज गोइंग टू हैपन, लेट अस सी। दैट्स अ वेरी इंपॉर्टेंट कंडीशन व्हाट आई एम डिस्कसिंग नाउ। सो हियर m1 इज इक्वल्स टू m2, दोनों बराबर है, तो लेट अस से दोनों किसके बराबर है, जस्ट m के बराबर है, जस्ट आई एम राइटिंग से, मींस वी आर कंसीडरिंग इट। तो m1 इज इक्वल्स टू m2 एंड दैट वी आर जस्ट कंसीडरिंग, बेटा यहाँ पे जो है ना हम कंसीडर कर रहे हैं दैट वैल्यू इज इक्वल टू m, लाइक 5 kg 10 kg जो भी है m kg हम कंसीडर कर रहे हैं। तो अब आप इसमें सब्स्टिट्यूट करेंगे और इसमें सब्स्टिट्यूट करेंगे और आप देखेंगे, यू आर गोइंग टू चेक कि भाई व्हाट द फाइनल रिजल्ट वी आर गेटिंग, एंड दैट फाइनल रिजल्ट 100% विल सरप्राइज यू। ठीक है, देखिए द फर्स्ट वन v1, if I say v1, m1 both are equal to what, m, so in place of m1 I will write m minus m into u1 by m1 plus m2 m plus m plus 2m, m2 is m only, so this 2m, this is what u2 by m plus m. Now students pay attention, this m minus m, it is 0, 0 into u1 it is 0, 0 divided by something, the complete term, now this becomes 0, ये 0 बन गया। When this is 0, what is this v1, v1 is equals to 2m into u2 by m plus m, that is also 2m, 2m get cancelled, v1 is equal to u2, v1 is equals to u2. Now what is v1 in the figure, just check the figure, v1 is the final velocity of the first body, v1 is the final velocity of the first body and v2 is the initial velocity of the second body. What we have understood from this, that is after the collision the final velocity of the first body is same as the initial velocity of the second body, मतलब velocity यहाँ पे exchange हो गई है। Try to understand, v1 is the final velocity of the first body after collision and u2 is the initial velocity of the second body before collision. तो ये दोनों बराबर हो गए, दैट मीन सेकेंड बॉडी की जो वेलोसिटी थी ना बेटे, अब आ गई है द फर्स्ट वेलोसिटी, फाइनल वेलोसिटी ऑफ द फर्स्ट बॉडी। सो लेट अस सी द सेकेंड वन, इसमें सब्स्टिट्यूट कर देखते हैं हम क्या मिलता है हमारे को। दिस इज व्हाट v2 इज इक्वल्स टू, हियर आल्सो वी राइट m minus m by m plus m into u2 plus this is what 2m by m plus m into u1. So what we are getting, this part you can see clearly, this part will be 0, so this is what v2 is equals to this, I can say 2m by 2m get cancelled and we are getting a u1। क्या मतलब हो गया यहाँ पे, ट्राई टू अंडरस्टैंड क्या हो रहा है बेटा यहाँ पे। देखिए फाइनल वेलोसिटी ऑफ द सेकेंड बॉडी इज सेम एज द इनिशियल वेलोसिटी ऑफ द फर्स्ट बॉडी, जो फर्स्ट बॉडी जितनी वेलोसिटी से मूव हो रहा था आफ्टर कोलिजन, अब ये वही वेलोसिटी से सेकेंड बॉडी मूव होंगी। इन शॉर्ट आई विल से दैट जो भी वेलोसिटीज होते हैं बिफोर कोलिजन, immediately after collision the velocities will get exchanged, velocity क्या हो जाएंगे, exchange हो जाएंगे। तो मैं शॉर्ट में यहां पे लिख सकता हूं velocities are exchanged, यहां पे velocities exchanged हो जाएंगे। तो अब आपको जो है एक चीज मैं बताता चलता हूं यहाँ पे, आपको इस तरह के जब कंडीशन आता है या क्वेश्चन आता है जहां पे मास ऑफ द बॉडीज दोनों के मासेस इक्वल है और दे आर मूविंग विद डिफरेंट वेलोसिटीज, आपको क्वेश्चन पूछा जाता है बेटा आफ्टर कोलिजन व्हाट आर देयर वेलोसिटीज, तो आप ज्यादा सोचना नहीं है। देखिए मैं आपको एक एग्जांपल देता हूं, यहाँ पे आइए इसी पर हम एक एग्जांपल करेंगे। दिस इज वन, सपोज आई से one body is there of mass 2 kg. This body is moving with velocities 3 meters per second. Now this body is colliding with another body of mass 2 kg which is moving with 7 meters per second. This is before collision. And after collision, if I ask you after collision what are their velocities, means just you have to see दोनों के masses बराबर है, तो आप ये 3 meters per second 7 meters per second है, तो अब आप यहाँ पे problem solve नहीं करेंगे. You don't try to apply this formula and don't try to waste your time during exam. Time plays a very important factor. So there, if you have the two masses same, you need not to go for solving, just without thinking, say this is 2 kg, this is also 2 kg. So the first body is moving with 7 meters per second and the second body is moving with 3 meters per second. Thus the velocities will get exchanged. I hope you got the condition. Now students, we move for the second case, that is case 2, in which we are considering the target body, that is the second body is at rest. What do you mean by the second body is at rest? Means we say it is its initial velocity as 0. So that is u2 is equals to 0 because the second body is at rest. So one condition we take u2 is equals to 0. This is the main condition. The second body is at rest. Second body is at rest. So when the second body is at rest, u2 is equals to 0, then what do you say about this term? ये term क्या होगा यहाँ पे? What do you say? ये तो 100% बेटा हमको solve करने की जरूरत नहीं है, ये 0 हो गया. ठीक है, अब आइए next part. This is u2. Here also u2 is there. u2 as 0. If you multiply this or divide by this something, again यहाँ पे भी हमारे को 0 हो गया. So that means v1 is equal to m1 minus m2 into u1 by m1 plus m2. Small formula. The formula has been reduced now. And v2 is equals to this part. And what we are seeing here, all the conditions, what we can expect. The first condition under when the target body is at rest, we are going to discuss 3 conditions. All the 3 conditions are very, very important as far as the competitive level is concerned. All these 3 cases, sub cases, I can say what we are going to discuss under this main case, all you can expect as a question itself. So let us see one by one. The first one, if m1 is equal to m2. What do you mean by m1 is equals to m2? The masses are equal. मासेस यहाँ पे क्या है, इक्वल है. चलिए बेटा हम देखते हैं मासेस इक्वल है तो क्या क्या हो रहा है, हमारे क्या मिल रहा है. तो अगर मासेस इक्वल है तो लेट अस सी ईच मास इज इक्वल टू m. दिस इज वी आर कंसीडरिंग, से इट इज m1 is equals to m2 is equals to mkg of mass. तो अब हम देखते हैं फर्स्ट कंडीशन. व्हाट इज दिस फर्स्ट कंडीशन हियर? v1 is equals to what is this? Because this part is 0, you need not to think for this, just इसमें substitute करेंगे हम. This is what? m minus m by m plus m into u1. So what is m minus m here? M minus m is 0. So 0 by something, 0 into something, it is 0. That means u1 is 0. Now let us go for v1 is 0. Let us go for v2. What is this v2? v2 is equals to, this is 0, this part is 0 because the second target body is at rest. So let us go with this. This is what? 2m. m1 and m2 both are equal to m. So therefore a 2m by m plus m by m plus m into, this is u1. So what we are getting? v2 is equals to 2m by 2m get cancelled, and here it is v1. Now what we can say here? The second body is at rest. Try to understand. पहले जो है ना बेटा कोलिजन से पहले सेकंड बॉडी रेस्ट पे था, लेकिन आफ्टर कोलिजन दिस द फर्स्ट फाइनल वेलोसिटी ऑफ द फर्स्ट बॉडी ये 0 हो गया, और फाइनल वेलोसिटी ऑफ द सेकंड बॉडी इज सेम एज द इनिशियल वेलोसिटी ऑफ द फर्स्ट बॉडी. क्या हुआ यहाँ पे? यहाँ पे भी वेलोसिटीज एक्सचेंज हो गई. दैट मीन्स व्हेनेवर द मासेस आर इक्वल द वेलोसिटीज क्या हो रहे हैं, एक्सचेंज हो रहे हैं। इसको मैं आपको डायग्राम में देकर बताता हूं और एक एग्जांपल में मैं आपको देकर बताऊंगा। देखिए, ट्राई टू अंडरस्टैंड। यहां पे दिस इज एन एग्जांपल फॉर दैट। ओके, दिस इज एन एग्जांपल। नाउ सपोज a body is there, one body is there of mass. What I can say here, mass is I will take the mass as m is equals to some 1 kg. I'm just taking it, and this is moving with the velocity, I'll say it is 5 meters per second. When this body comes and collide with another body of mass same 1 kg, और इसकी velocity कितनी है बेटा, जीरो है। इनिशियल वेलोसिटी, इट इज एट रेस्ट। तो आपके लिए मैं थोड़ा सा और क्लियर कर देता हूं। दिस इज u1 एंड दिस इज व्हाट, u2 इज इक्वल्स टू जीरो। दिस इज एन एग्जांपल आई एम गिविंग। तो ये बॉडी जब इसको कोलाइड होगा, तो एज पर द सिचुएशन द मासेस आर इक्वल, तो वेलोसिटीज क्या हो रहे हैं, यहाँ पे एक्सचेंज हो रहे हैं। सो देयरफॉर व्हाट आई डू हियर इज, आफ्टर कोलिजन क्या होगा यहाँ पे, द फर्स्ट बॉडी, दिस इज ऑफ मास 1 kg, दिस इज 1 kg। तो ये कितना होगा बेटा, क्योंकि ये टकराया है किससे, 1 kg से, विच इज एट रेस्ट, वेलोसिटीज एक्सचेंज होते हैं। तो ये v1 इट इज जीरो, और ये जो सेकेंड बॉडी जो है ना, दिस इज ऑल्सो ऑफ 1 kg, दिस इज v2, एंड दैट इज इक्वल टू द इनिशियल वेलोसिटी ऑफ द फर्स्ट बॉडी, दैट इज 5 meters per second। ये मूव होना शुरू करेगा, ये रुक जाएगा। क्या मतलब है यहाँ पे, दिस इज एन एग्जाम्पल व्हाट वी गेट इन अवर बिलियर्ड बॉल्स, राइट। बिलियर्ड बॉल्स में क्या होता है बेटे, आप बोर्ड पे थोड़ा सा इमेजिन करिए, एक बोर्ड इमेजिन करिए जहां पे बॉल्स पूरे रखे हुए हैं, और आप स्टिक से फर्स्ट बॉल को धक्का देते हैं, तो क्या होगा, ये बॉल अगले वाले बॉल को टकराएगा। एग्जैक्टली अगर ये इलास्टिक कोलिजन होता है तो ये जाकर टकराएगा, और ये वाला बॉल जो है ना रेस्ट पे आ जाएगा, और ये वाला बॉल आगे जाएगा। That is the same situation what we are expecting under this one. I hope you have understood. Please take down. Now students, in the case 2 only, the first case we have seen both the masses are equal. The second case, the second sub case is here. What I consider the second one is m1 is much less than m2. m1 is much less than m2. What do you mean by this much less than? That means m1 is negligible when we consider m2. फिर से मैं बताता हूं, m1 बहुत थोड़ा है बेटा, mass is very very less when compared to the mass of the second body m2. So under this situation क्या होगा, I am saying that again, I am saying m1 is negligible when compared to m2. That means m1 is almost zero. Zero नहीं होता है, but to get the condition we are considering it to be zero. तो इसके लिए मैं बता रहा हूं आपको, देखिए अगर हम देखते हैं बेटा, तो m1 is equals to is much less than m2. what I do here is m1 जो है ना बेटा, हम मान के चलते हैं किसके बराबर है ये, it is not equal to zero. I have written almost equal to zero. ठीक है, this is m1 is equals to zero, and what I do here is m2 की जगह पे हम लेते हैं बेटा मास m. Now let us substitute. ये देखिए, the second target body is at rest. I'm not changing the main condition. ये जीरो हो गया, ये जीरो हो गया, इसको आप डिस्टर्ब नहीं करेंगे. What is this v1? Let us see. v1 is equals to m1. m1 is zero minus m2. What is m2? I am considering it as m by m1 0. What is m2? It is m into what is this, u1. So v1 is equals to, you can see the condition, this is minus m by m, this to get cancelled. So v1 is equals to minus u1, the first condition. Now let us go for v2. चलिए, we go for this v2 also. This is already zero because the second body is at rest, target body is at rest. इसमें substitute करेंगे हम. That is equals to 2 m1, it is zero, negligible, into u1 by m1 plus m2, 0 plus m. So directly I will write it is to be 0. क्या मतलब है बेटा, यहाँ पे देखिए, हम वर्ड्स में समझा रहा हूं. फाइनल वेलोसिटी ऑफ द फर्स्ट बॉडी इज इक्वल टू द इनिशियल वेलोसिटी ऑफ द फर्स्ट बॉडी इटसेल्फ, बट इन द ऑपोजिट डायरेक्शन. ये जो नेगेटिव आया ना बेटा, डायरेक्शन ऑपोजिट की बात कर रहे हैं. नाउ व्हाट इज दिस, फाइनल वेलोसिटी ऑफ द सेकेंड बॉडी is 0. What was the initial velocity of the second body? 0. मतलब ये जो सेकेंड बॉडी है कोलिजन के बाद भी रेस्ट पे ही होगा, लेकिन फर्स्ट बॉडी में क्या चेंजेस आ रहे हैं, जब ये फर्स्ट बॉडी जाके सेकंड बॉडी से टकराएगा, ये वापस आएगा उतनी ही वेलोसिटी से. I'll give an example here. This is an example what we have in our daily life. This is a wall. This is the wall. You can see this is the wall. And I take one ball. This is the ball. When this ball go and hit the wall, और आप गौर से देखना यहाँ पे वेरी इंपॉर्टेंट थिंग, जब हम बॉल का जब मास कंसीडर करते हैं ना बेटे, the complete mass of this wall with complete mass of this wall, this mass is negligible. That is thousands of kg में होता है. Wall का mass thousands of kg में होता है, लेकिन whereas the mass of the ball it will be in just grams में होता है ये. No doubt mass will be there, but it is negligible when compared to the mass of the wall. और wall देखिए बेटा रेस्ट पे ही है. Wall is at rest. Second body, target body is at rest. Wall is at rest. तो ये जब टकराएगा बॉल विथ इनिशियल वेलोसिटी u जाएगा, और ये जब वापस आएगा ना बेटे, फाइनल वेलोसिटी दैट इज v1 इज इक्वल्स टू माइनस ऑफ u1. जितनी वेलोसिटी से जाएगा अगेन इट विल कम बैक विद द same velocity. And you can see clearly under this situation the velocity of the wall before collision and the velocity of the wall after collision both are same and equal to 0. ये wall पीछे नहीं हटेंगी बेटा collision के दरमियान में. ठीक है, I hope you have understood the case 2 also. Now students, here in what I can say, the third step case under the main case 2, here the situation we have to imagine the second body is much less than the first body. That means we can say this is the situation C where we are considering m1 is much greater than m2. That means here m2 is negligible. M2 is much less than m1, or we can say m1 is much greater than m2. So under this situation m2 is negligible. So what I do here is m2 is almost equal to 0 and m1 I will consider it to be m only. Now let us see what we are going to get. So this v1, this is v1, m1 minus m2, that is what is m1? M1 is m minus m2, m2 is 0 by m1 is m, m2 is 0 into what is this u1. This part is already 0 because the target body is at rest. Now this is v1 is equals to m by m into u1. This to get cancelled. So v1 is equals to u1. What do you mean by this? Final velocity of the first body is same as initial velocity of the first body itself. Now let us go for the situation that is for v2. v2. What is this v2? v2, this part is already 0. So here we go for 2. What is m1? m1 we have considered it to be as m by m plus 0 into what is this? u1. So final velocity of the second body, if you see, this is 2m by m into u1, this to get cancelled. So v2 is equals to 2u1. क्या मतलब है बेटा? The final velocity of the first body is same as the initial velocity of the first body itself. There is no change in the velocities before and after collision. लेकिन इसको अगर आप गौर करेंगे, final velocity of the second body will be twice the initial velocity of the first body. क्यों? The reason यहाँ पे देखिए, ये तो 0 है. Initial velocity of the second body is 0, लेकिन final velocity of the second body is twice the initial velocity of the first body. इसको हम कैसा समझेंगे? What type of question you can expect? Let us see by giving an example. This is an example. Just imagine a ball, a big ball is there. यहाँ पे एक बॉल है बेटा, जो है almost आपका मास है that is 1 kg. 1 kg means how much it will be like 1 kg? It's, I can say it is 1000 gram. Either you say 1 kg or 1000 gram. Now this is moving with velocity. Just imagine this is moving with velocity 5 meters per second. And the second body here, you can see itna sa. I hope you are getting that dot. ठीक है, तो that is a second body because second body mass is almost 0, negligible है. तो ये इस तरह से उतार रहा हूं बेटा, और इसका मास मैं लेता हूं, जस्ट इमेजिन दिस इज जस्ट 1 ग्राम, and this 1 gram mass is at rest. That means initial velocity of the second body is 0. अब ये बड़ा वाला बॉल जाएगा और उसको जाके हिट करेगा. हिट करने के बाद what we observe is there is no change in the velocity of the first body because v1 is equals to u1. इसमें कोई changes नहीं आएंगे बेटा. तो यहाँ पे what I do, you know, I will draw another ball for this. ये इतना बड़ा, और ये जो है मूव होगा सेम वेलोसिटी से 5 मीटर्स पर सेकेंड की, लेकिन ये जो छोटा वाला जो बॉल है ना, नाउ इट विल स्टार्ट मूविंग विथ ट्वाइस द इनिशियल वेलोसिटी ऑफ द फर्स्ट बॉडी. कितना था इनिशियल वेलोसिटी? 5 मीटर्स पर सेकेंड है. अब ये कितनी वेलोसिटी से मूव होगा? 10 मीटर्स पर सेकेंड की वेलोसिटी से ये मूव होगा. I hope you have understood all the 3 cases of elastic collision under the condition that is case that is target body is at rest.